The next step of exercise a03 is going to have us kind of wrap all the remarks that we went through so far. Wrap them around and try to draw a conclusion. I told you sooner, a couple of videos sooner, that we're going to come back onto what's going on exactly with us trying to swap around a1 and a2. Well, if you want to swap around two integer variables, you need to pass to your function the pointers, the address of those two integer variables. Here we are trying to swap around a and b, a1 and a2, sorry, but we never passed a pointer on a1 or a pointer on a2 to those functions. So that was one thing. The second thing that we just mentioned at the end of the previous step of this exercise was that anyway, you cannot assign anything to a1 and a2. If anything, you should consider a1 and a2, the name of the arrays in the main, as being some sort of pointer constant. Okay, they represent a memory address, so everybody is really keen to assimilate them to pointer, but you cannot assign anything to them, so they're not really pointers, right? Plus they don't occupy their own memory. I mean, this is really weird. There is a very subtle difference there. So back to the main. When we put together those two pieces, what does that mean? Well, it means that when I call swap array, even if I was trying to pass the address of a1 and the address of a2, that would not make any sense, and I would not be able to actually swap the content of a1 and a2 because a1 and a2 are not pointers. So this last version of our code is going to use a slightly different approach. I'm going to declare two pointers on int, p1, p2, assign them to a1 and a2 respectively. Then I'm going to pass the address of p1 and the address of p2 to my function, meaning that I'm expecting this function to be able to actually swap the content of p1 and p2. So it's the next best thing compared to what I was originally set to do. I'm not going to be able to modify a1 and a2 so that they point respectively to each other's content, but I'm going to use pointer instead to manipulate my arrays, and I'm going to be able to swap around those pointers. The first thing I'm doing, I'm going to try to pass address of p1 and address of p2 to my swap arrays 3a function. Here's a reminder of the code. Okay. The code was not modified. I'm still using the same version 3a of my function. I'm accepting an int star p1 and int star p2. What happened when I call swap arrays 3a with ampersand p1 ampersand p2? Well, the first thing that happened is type mismatch. Okay, here you are expecting a pointer on int. You are passing here the address of what? The address of p1, which is actually what? The address of an int. So the address of a variable which contains the address of an int, this is a pointer on integer. This is not a pointer on integer. So there is not even a need here to, you can run that if you want to convince yourself, but this is really a trivial case in which the compiler is going to tell you, I'm not sure exactly of the matching of what you are trying to pass here, regardless of the logic of the code itself. So draw a stack diagram once again, if you need to understand, okay? Make sure that you understand also the difference between an int star and an int star star in this particular context. Now that we see that this didn't work quite well, we're going to try something different. Here is version 4a of our function, where we acknowledge that if we pass the address of p1 in the main and the address of p2, then our parameter needs to be double pointers on int. That means that we need also to modify a little our code. TMP is still a pointer on int. Why? Well, if after this explanation you're not sure exactly, 100%, well, you know you have something to post on the forums then. TMP is going to be assigned star p1. So we are going to work this one up with a little stack diagram again. Let me take a new sheet of paper and let's go back to our code and let's try to figure out what happened in this context. Inside of my main, I will have my two arrays, a1 and a2. Okay, then I will have my two pointers, p1 and p2. So I'm going to represent all of this on the stack for sake of simplification. Okay, so this is going to be the main function activation record. So this is my stack. I'm going to start by having a1. Okay, a1, which pretty much represent, I'm going to put them horizontally, even though I should do it like vertically, but there we go. A1 and A2 are each going to represent arrays of two integers. Okay. P1 is going to be a 4-byte pointer. P2 is going to be a 4-byte pointer. Let me go back to the code here. What do I have happening else in my main? P1 is assigned A1, P2 is assigned A2. Okay, so P1 is assigned the address of A1, 0. P2 is assigned the address of A2, 0, which boils down to say that P1 here is pointing to this element, P2 here is pointing to this element. Okay, what else? Then I call my function. So a little bit of system information goes on the stack, return address, and so on and so forth. And then what do I have inside of the activation record of my swap function? Well, let's have a look at the code again. I'm talking here about the new version. Okay, this is the one I want to understand. So swap arrays for A as P1 and P2, which are pointer on int. Okay, so let me take some room here for P1. Take some room for P2. They are pointers, so they are 4 bytes each. Now, what do we do with those values? Well, we have a local variable TMP, which is a pointer on int. So I'm going to add this one to the stack diagram. We have barely enough room here. We have this pointer TMP, and then we start our assignment. Wrong window. Let me go back here. TMP is equal to star P1. Well, double check the types first. TMP is a int star. What about P1? P1 is a pointer on int. So dereference P1 once, and you get on the pointer on int. Pointer on int is an int star, so we are assigning apples to apples here. TMP is equal to star P1. Let's go back to the stack diagram. TMP is assigned star P1, and it would help if actually I would have completed here my stack with the values that are actually passed. So hold on a minute, sorry about that. Let's go back to my main. Inside of my main, I'm going to call with address of P1, address of P2. So I'm talking about the P1 and P2 in the main. So address of P1 is here. I'm going to assume that P1 therefore points to the parameter P1 points to the local variable P1 in the main. P2 receives the address of P2, which means P2, the parameter P2 points to the address, points to the local variable P2 inside the main. Okay, now that my stack diagram is a little bit more complete, I can go back to my code, wrong window again, and see what's happening. TMP is assigned star P1. Okay, TMP is assigned star P1. This is P1 here. Star P1 means I dereference once. I am now looking at this. This is what star P1 is. So TMP is assigned star P1. Okay, TMP is equal to address A1, 0. Next, what happens? Star P1 is assigned star P2. Okay, so this is P1, this is star P1, boxed in blue, is assigned star P2. This is P2, star P2 is this. So I'm going to modify here the content of star P1, which correspond to the content of the variable, the local variable P1 in the main. I'm going to modify it so that it contains now what? The content of star P2, which is the content of local variable P2 in the main. That is address of A2 index 0. And you can see already from here on that this is working because we are modifying the variables in the main. We're not just modifying P1 and P2 in our swap function activation record. So let's have a look at the rest of the code. Star P1 equals star P2. Done. Star P2 equal TMP. So let's do that one. Trace it on the stack diagram. Star P2 is this equal TMP address of A1, 0. So let me erase this. P2 local variable in the main is receiving the address of A1, 0. Then what? When I'm done, everything on the activation record of swap goes away. So all of this here disappeared. That's okay. We made our modification in the variable P1 and P2 in the main. So even though we lose all of our temporary variable, etc., we still have what matters. And what matters is that if I update those rows to reflect the change in P1 and P2, I have now P1 pointing to the first element of A2 and P2 pointing to the first element of P1. P1. I can remove this red arrow here. And this is a swap that we were talking about implementing. So this is explanation of why this is working from the perspective of the stack diagram. And this is really the only thing you need to worry about. For all of those exercises, you need to go over them again and make sure you can derive a stack diagram explanation of what is going on step by step. If you can do that, then that means you understand what you're writing. If you cannot do that, don't fool yourself into believing that you can program. If you cannot explain what the code you write is performing, then this is kind of saying that you are shooting a shotgun blind. Okay, you don't know exactly what happened, but you know that sometimes it works, sometimes it doesn't work. So we are going to try to steer away from that. Here is a code that implements all of this. I can remove my exit statement now. And we can save, compile, execute to just make sure which version is functioning and doing what. So there we go. Let me look for a.out. Here we go. So we have all the tests here. Initial value, version 1 works, version 2 works, version 3a doesn't work. Version 3b didn't work either. Version 4a, the one that we lastly implemented, it works as well. Notice that in the main, when I'm displaying actually P1, P2 with the display array function. Okay, not A1, A2, otherwise it would not work. So I'm going to leave the code on the screen and we are done with this exercise.